Okay, by my count, it's 1 p.m. So we're gonna officially start the recording and start this presentation. To answer everybody's initial questions, yes, this is being recorded and everybody will have access to this recording. Additionally, we will be putting this up on our YouTube channel, which if you don't like and subscribe, I suggest you get out there and do that. We have a lot of great videos up there. And this is the first of many webinars we will begin doing and posting on our YouTube channel. We have disabled the actual chat feature, but that doesn't mean we don't want your input. In fact, under the Q&A portion, you can submit a question and we will get to those questions toward the end, and I will publish them in this room, and hopefully we have time to get to that. Right now, I'm going to throw it right over to our presenters, which we have Nathan Banke, our Director of Education, and Dave Giles, who is our all-knowing electric vehicle expert, who we've recently brought on staff full-time to talk about integration of electric vehicles into your classroom. Go ahead and take it away, guys.
Well, thank you, everyone. This is exciting, seeing all the people from all around the country coming into this webinar on the integration of electric vehicles into your classroom. I've invited Nathan along as well, so he'll be interacting with us here today. The presentation is approximately about 35 minutes long to about 40 minutes long, depending on how many questions Nathan has and comments. But we want to leave it open at the end for questions from you guys, and anything that you want to know or talk about or ask a question, just shoot it in the question area that Jimmy was talking about, and then we'll be happy to try and facilitate an answer to you, or even get back to you after if we have enough questions. We may not be able to get back to everyone on the chat here, but definitely we will get back to you personally, with helping you with some of your questions you may have. So anyways, do you want to say anything, Nathan, there? Or?
Oh, I think we're ready to go.
Okay, so like Jimmy says, I was brought on to ConsuLab to help them with the electric vehicle side of things. I've been doing EV since 2004 with hybrids, and then getting into EVs, taught at community college for over 12 years. Currently, I work with ConsuLab as an EV education specialist, working with products and curriculum to help schools develop their EV programs and help them integrate the EV into their classroom. So currently, I do work with OEMs as well. So there's lots going on in the world with electric vehicles, not just here in North America. As we continue to see growth of EVs happening, we know that we now have to start making those decisions to start bringing electric vehicles into the curriculum, into the programs, into training, and there's so many opportunities. And I do a lot of presentations, and one of the presentations I like to say is that electric vehicles are not a threat, but an opportunity. So which we're going to see some of the really cool stuff that hopefully ConsuLab can help with your programs and help you get started with EVs. Like I said, this course or this little webinar is a high level. There's lots of information here, so we want to be careful that we don't get too far into an area. So we have planned other webinars as well, once a month, that Nathan will discuss at the end of this presentation. So yeah, so I think we're good to go.
So we can see from the interest in how many attendees we've got, how much interest there is for this opportunity for so many programs in integrating EVs into their classrooms.
Right, so perfect. Yeah, that's so true. So the reality is that we'll see more changes in the next 5 years in the automotive industry than we've seen in the last 50 years. So, with advanced vehicle technologies, AI, electrification, battery technology, drive unit technology, we're seeing more and more acceleration of this, and even still, it's even advancing the combustion gas engines into more efficient, more powerful engines. I know some people always say about electrification, oh, it's, these are electric vehicles and so on. But it's really prompted the auto industry to really relook at the gas powered side of things to make them more powerful, make them go further on fuel, as well as redesigning a lot of systems within their own process, because they know that electrification is here. People are driving electric, and they want to be able to match that with the combustion side as well. So a lot of technologies are happening around the around vehicle technology all the way around, and we're even going to start seeing some new technologies like hydrogen and stuff as it's starting to be integrated into our fleets and our roads and so on. Okay. So like I say, it's not a new technology. I'm not going to spend a whole lot of time here in the history of electric vehicles, because this is, once again, this is for you guys. But just to think about that, electric vehicles were around even well into the earliest of gas-powered vehicles. The Detroit Electric Motor Company made significant amount of electric vehicles, up to around over 10,000 electric vehicles. And I always like to fool around is that in the early 1900s, Henry Ford's wife actually drove an electric vehicle till the early 1930s. And she drove electric vehicles due to the fact of the ease of use, the simplicity of it, the power, and the reliability. So the technology is not new technology. And in fact, even some of the systems that they used back then are still the fundamentals of our systems today on electric vehicles. So just keep that in mind when somebody says, "Oh, these new electric vehicles." Well, actually, they're not really that new. There's a lot of history behind them. It just seems recently they've taken off, and partially because of manufacturing processes, battery technologies getting way better, and the drive systems and electronics and controllers and that really do help accelerate the EV side. So, okay, we're moving on. So this session here, we're going to be discussing, obviously for schools and so on, is building a program. What does that look like? Sometimes it's where to start, how to integrate some of the information into your curriculum, and where do you get that information and so on. So that's kind of what we're going to talk a little bit about today. As well as some of the challenges with EV integration. What does that mean? Some of those challenges that are posed, whether it's cost, time, how do I fit that into a program that's already jam-packed with information and courses that we have to cover and curriculum that needs to be developed, and like we don't have time for that. So we're going to talk a little bit about that, as well as we're going to look at some of those sources and information that can help you as well with with this integration of EVs. And when I talk about EVs, I'm not talking just about electric vehicles. I'm talking about PHEVs as well as hybrids as well too. So we'll see that as we move along here. Is that good, Nathan? Do you think anybody add anything?
I think we're going along good.
Okay, so good. So and obviously we're going to look at some of the things that ConsuLab can help out with as well too. So we want to make sure that we're a source here for information. Once again, we're about education. Whether it's a gasoline vehicle, a diesel powered vehicle, electric vehicle, and even as we move into hydrogen systems, it's all about what's on the road. It's what's all about what your students are going to be experiencing with vehicles and repair and so on. So, so that's the focal point, is that we're really, want to really help out with the education side of getting EVs into your programs to help, deliver that material to make the students better students when they go out into the workforce.
Absolutely.
So what are some of the changes with electric vehicles? And so once again, it's almost like back in 1984 when carburation was being phased out into fuel injection, and we're trying to, to mask like, oh, the coolant temperature sensor is kind of like the choke circuit, and and the throttle position sensor, and and so what they've done in that process is, even with electric vehicles, it's kind of the same idea, is that we have no engine with an electric vehicle, obviously, unless it's a PHEV or a hybrid. But we've replaced with electric motors and electronics to be able to control those systems. We have no transmissions, not conventionally in the sense. We have power reduction units and so on, but we have direct drives and gear reduction. So, they were replaced with replace complex transmission systems with, just gear reduction systems. And yes, there is a Porsche Taycan with a 2-speed transmission, but once again, it's a very unique gear reduction style unit that's using conventional components with a complex electronic system involved. So, and we've eliminated no emission systems. There are no emission systems, obviously, on an electric vehicle, a pure electric vehicle. But we've increased the safety in the high voltage components within the vehicle. We've eliminated the fuel systems and related parts, pumps, gas tank, lines, all that's gone, but they've been replaced with batteries and high voltage cables. So, so it's very similar in the sense of storage of energy and transfer of energy have been replaced with your cables and batteries. And then, of course, we have no starter alternator components. You don't need that on an electric vehicle. And even on hybrid vehicles, they've been eliminated because of their MGs and so on. But we replace them with DCs and contactors and pre-charge contactors and converters and inverters. So all these new components have been added to the vehicle. But one thing I'd like to stress is that when we talk about the elimination of components and replaced by, our cars are still the same. Our vehicles are still the same. The bodies, the chassis, the lighting systems, the 12-volt systems still operate the same way. Our ADAS systems are incorporated into whether it's an ICE vehicle or an electric vehicle. So either way, it's like, so that hasn't changed. It's really our powertrains have changed.
There's a huge amount of overlap between electrically driven vehicles and conventionally driven combustion vehicles. And I think a lot of times instructors, technicians, students, and people in industry see this huge change coming in we're no longer going to be using this technology, and oftentimes electric vehicles look simpler. And in some cases, I think they might be missing the boat there a little bit, because there's a lot of opportunity in training. There's a lot of overlap. So a program, a college level program that's well established, that's got a great program, great throughput of students and everything, there's not going to be that many changes to the core elements of their program once they get into EVs. A lot of schools we're seeing in different jurisdictions either adding another level of education to it at the end, or they're blending it in throughout the program right from day one. And really, there's not going to be these huge changes to your program. We're just going to talk a little bit about it all throughout. So.
Yeah, and that's exactly, and that leads us into the next slide, is that less moving parts means more training. So, and it's a different type of training. Like, it's understanding electrical, electronics, power flow. When we talk about safety, we're now into high voltage safety. We have, procedures, processes, workplace practices that are, focused around working with high voltage vehicles. And now, it depends on the level of service that shop or that technician is going to be doing. So, a lot of vehicles currently are basic maintenance and servicing of the systems. The batteries and high voltage components are still years away because of warranties and so on on the vehicles. So
if we were to make a comparison there, if we look at combustion vehicles and schools that are teaching like maintenance and light repair and not going too far in depth in transmissions or engine mechanical and internals, what would be the equivalence of the areas that they're not going to go too far into on an EV, Dave?
So so you're not going to get into battery rebuilding, battery repair, even into the high voltage systems. If there's a motor failure, stator failure, something happens internally, you're going to be replacing that gear reduction unit as a whole. You're not going to be tearing out the stator to replace it in most cases. So it's going to be replacement parts. We're going to see more used parts coming into the market. Up here, we deal a lot with the auto recyclers associations. and they're starting to ramp up on EV parts and so on. So so really it's starting to walk before you can run. So
Yeah.
that philosophy is like getting that safety, get the level of maintenance required on the vehicle, understanding the fundamentals of an electric vehicle and how it works and what it does, and get the terminology. And we're going to talk a little bit about that as well
Yeah.
too. So these are things that you can start off with without having to think about, oh my gosh, we need a battery, we need arc flash protection, we need, but meanwhile, yeah, the students haven't even understood the basic fundamental of, how an electric motor even operates or even how it powers the vehicle. So, and even getting into the safety aspects of it. So there's many levels that can be, ground level stuff that can happen before, start looking at more advanced services on an electric vehicle. Okay, good. So, oops, I got a second to put this here. So why are people buying electric vehicles? Well, because of convenience, cost, range, operability of the vehicle. There's many reasons why people buy electric vehicles, but it comes down to, at the end of the day, whether, argumentatively or not, these are vehicles that are now here. They're in our systems, they're on our streets. And we need to be able to help address the repair and service of these vehicles. And so that's an important part of it is I know I get a lot of people asking, the basis of, electric vehicles, why are we doing them? They don't go that far, they don't do this and don't do that. And it's like, well, you know what? It doesn't matter. People are buying these cars, they need to be serviced. They need to be, they need to have their maintenance done,
Yeah.
and people are willing to pay for it. So we need to train people on how to work on these vehicles and do so safely as well.
Yeah. And for us, at ConsuLab, what that means for us is that whatever's on the road, whatever's being driven and needs service, it needs to be taught. The students need to learn it, which means we're going to be there to help you guys to help get the students up to speed with that technology. So whether it's electric vehicles, the combustion vehicles, or in the future, other choices, we're going to be helping teach what needs to be taught.
Yeah, so it's so people always ask me, they go, so what kind of vehicle do you drive? It must be an EV. And Nathan already knows. Yes, I have an EV. Obviously, I drive an electric vehicle.
Yeah.
But I also have a Dodge Ram supercharged truck with 31-inch tires on it, and I have a convertible gas-powered vehicle. So it's like, so I love cars, and I think that's where it comes down to. When you ask somebody about, what is their dream car? I know that I was on a call earlier, and you ask students, what's your dream car? And they'll come up with all these different types of vehicles, and that's really what the industry is all about. It's just the love and the passion for transportation in any different way, in every different type of powertrain that's available. So yeah, some people, oh, you must be a tree hugger or something. Oh yeah, I got a Dodge Ram truck, and it's probably the worst vehicle on the road in fuel. So. So moving on here, just I want to get through some of the, I'm not going to go through all the terms here, but just some of the foundation stuff that you can start introducing would be some of the terminology, learning the terminology, what those terms are. It is a lot of new acronyms that are right there. There's new systems in place, but even just getting through some of the basic terms and how they relate to an ICE-powered vehicle. And that's what I always try and do whenever I'm teaching a course, especially at a fundamental level. It's just a basic introduction to EVs. I really try and get people to understand the comparison between some of the terms to the gas-powered vehicle. So, for example, like state of charge, what is that? That's like the level of fuel in your tank. What is the state of health of the battery? That's like a condition of the gas-powered engine. As compression is lost, you lose the power potential and so on, and even range that the vehicle can get, no different than state of health. And when we talk about kilowatt hours, how big that battery is, how big that gas tank is. So these are some of the things that, as as simple as it sounds, it gives a relationship to what people already know. So that it makes more sense when you start talking about, well, this car has a 90 kilowatt hour battery compared to this 65 kilowatt hour battery. What does that really mean? And that's, the size of the gas tank, the size of energy that can be stored in that gas tank. So that's the idea. We see some new devices, systems, high voltage interlock systems. We have service disconnects on vehicles for some vehicles anyways. What do they do? How do they work? So when do I disconnect it? That's the other thing. If I'm doing a brake caliper service on a vehicle, do I have to go and unplug the service disconnect
Power
to do
down
that
the high voltage system? Yeah.
Or put air in the tire. And it's
Yeah.
funny because I have a picture. We're going to share it later on once I get it finished. But I really have somebody in all the protective clothing, and from arc flash to the mat to the gloves to the hook beside them, and so on, and they're putting air in the tire on an electric vehicle. And so it's really what are you doing in order to require different levels of PPE? So and what procedures are required?
Yeah. One thing that I'd like to underline here is that this a first step for any program, whether it is a high school program, college program, the very first step, if you're not already doing this, I know a lot of schools already are, but again, we're talking about the integration of EVs into your classroom, is the very first step that any school can do today, is that from the beginning, in every class, whenever you're talking about a subject and that there is disparity, a little bit of difference between how it works on a combustion-powered vehicle and electric vehicle, you just mention, like Dave did, well, when you're talking about the chapter on fuel and fuel storage and fuel tanks, well, guys, if it was an EV, it would be the state of health of the battery or the state of charge or how many kilowatt hours, and just making it relevant and specific to the students. That's kind of one of the first levels of integration. I'm sure most of you are already doing that, but that's something that you can put into place now, is really looking at how can I take what I'm already teaching and just make it relevant to the EVs that their students are going to be seeing out in the field. The second level for me of this type of integration is around just making a list, and you can have your students to just go down the list of what are all the things you already know or you're already learning how to do at school that you can just go and do on an EV because it's exactly the same. There's a lot of levels of integration that they can do with that, and answering that, well, doing, depending on the brake job, it's going to be the same as if it was on a combustion powered car. So that type of integration can help a lot of schools to get started.
Yeah, and I agree. It's like, there's certain things that can be incorporated directly without a lot of background on. But once again, it's getting that base foundation of what is an electric vehicle, how do you identify it, and what are the precautions around working around certain systems on the vehicle. And that's part of the information, part of the training that they get. So it's a very important part of the integration of vehicles, especially into the industry itself, so, where you get a lot of shops that are not willing to or not wanting or may not even just know about how to even approach an electric vehicle for different types of services. So and thinking that these cars are super advanced vehicles that require special skills and that to work on. It really comes down to the basic fundamentals, understanding safety and so on, and how it operates. It's that operational side of them. So not going to spend a huge amount of time here. I want to move into the other stuff because of our time, but obviously we have 3 levels of different types of EVs out there, hybrids, and we have our PHEVs, our plug-in hybrid electric vehicles, and then our battery electric vehicles. And, really it comes down to battery size, range of the vehicle that really will start dictating the batteries, whether they're a 3 kilowatt hour battery all the way up to 150 kilowatt hour batteries and plus in some vehicles now today. And I also want to make a note here, if you're into a truck and transport program, into bus or coach, or doing that, there's a lot of commonalities within electric vehicles, whether the hybrid bus or battery electric vehicle that's being propelled. So the fundamentals do follow within the scope of the training that you could do, whether it's in the automotive program or the truck programs, about electric vehicle safety, components, operation, power flow, all these different aspects are all part of that. So one thing that I get asked a lot, I travel the world, and everyone knows that. So how long do the batteries last? And fortunately, where I live, I'm right by two major labs. One is the Tesla a lab with Jeff Dunn. It's about 4 kilometers from my house here. Then across the water is in Halifax is the RESL lab with Dr. Lucas Swan. It's in the bottom corner. And why I'm saying this is that they test these batteries and they actually design and build batteries. So for Tesla, Jeff Dunn is actually this lead scientist in battery technology in the world, and he develops the mixer, the construction science behind the battery cells, and he works directly with Tesla, same as Dalhousie University, and Lucas Swan down there. If you remember the EV1, obviously he's a little young to be working on the EV1, but his dad was the chief engineer at General Motors in California on the EV1 program for battery technology. And David Swan actually still lives in Nova Scotia here, but this is his son who's now doing battery testing and research on batteries and for secondary life of the battery. And this is where they test them, and this is how they know how batteries will last. So a battery like your cell phone, which I lost my cell phone here somewhere, but cell phones get about 150 to 300 cycles. That's why your phone only lasts about 3 years before you start really noticing a battery degrade on your phone, where you're not getting the 2 days out of your phone, you're getting 1 day because of degradation of the battery. Electric vehicles are a very different battery technology. They don't use the same technology that's in a cell phone battery. So we can't relate it to a cell phone other than, it uses a lithium style battery, where electric vehicles battery cycles are a lot higher, 15 to 3,000 cycles. And in fact, they're finding out now that battery cycle times can even be beyond that. Take that into a comparison. If you have a vehicle that can get about 500 kilometers per charge, and you can get about 2,500 cycles on that battery is designed to last 1.2 million kilometers. So just give you a little background. Let's say that car only gets 250 kilometers. I'm sorry, I'm using kilometers here, but if you can only get 250 kilometers out of that 500 kilometer cycle, that's still 625,000 kilometers on that vehicle, which means that the battery will outlast the vehicle. That means that these vehicles will need maintenance. These vehicles are going to be on the road longer. We're seeing a lot of electric vehicles, powertrains that are gaining in mileage. They're starting to get older. So once again, think about more on the side of that these vehicles are going to require routine maintenance. They're going to require the recommended maintenance service intervals on these vehicles, even beyond. And batteries are probably the least of the worry on a lot of vehicles for wearing out. So, do I add anything there, Nathan? Or
no, we're all good.
Okay, great. So one thing I do warn is that even though we talk about how they're very similar to our gas-powered vehicles and how they work, but never attempt to service or dismantle an electric vehicle without proper training and obviously safety equipment. And I like to add one more thing to that little slide there is information. I always try to put it the triangle of success is if you look at it, if you have your safety equipment, your equipment to work on the vehicle, you have your training, and you have your information. You have the 3 pillars required to be able to do a successful job. But if you're missing one of those pillars, then it's very difficult. So you can have all the equipment in the world and all the training in the world, but you don't have the service information to do it. Or so on, if you have the training and equipment, no service information, or you have the equipment and information with no safety or with any proper training, can make it very difficult. So that's something to think about, the 3 pillars when you're looking at it. Hey, we bought the equipment, we need to have the information, and we need to have the training as well for ourselves. Even as instructors, you need to be prepared as well for that. And the hazards that come with electric vehicles are, as I have in the bottom, chemical, there's electrical hazards, there's fire hazards, as well as electromagnetic. And it doesn't mean that these cars are going to burst into flames in your classroom, but just, once again, it's the, identifying and understanding and the processes around each one of these hazards that a vehicle has, and no different than an ICE or combustion powered vehicle as well. And just giving you some example here, I got a little clip up here. I'm going to show you some of the safety, the redundant safety systems, and talk a little bit about the video links and so on that we're incorporating into ConsuLab's website. But here I take a 240 volt, 48 amp charge cable level 2, and I dump it in a bucket of water. It just plugged into the vehicle. I plug it back in. And just to give an example of the safety around, the redundant safety systems, understanding how the systems work. I've done this, several times to show how charge stations work. And this is part of the confidence that we would like to help you with in understanding electric vehicles, whether it's a regen system, a high voltage battery, construction, safety around the battery, charging systems, and so on. I do have, we do have a website. It's on YouTube. It's All EV Canada. And there's probably about 30 or 40 videos on there. We're going to start moving the videos over to ConsuLab, so you'll see them on their YouTube page. But just for the intern, we have videos on battery tear downs. We have videos on gear reduction units, tear downs and explanation, steering systems, and so on. And even just an overview of a lot of electric vehicles. I even take in a Tesla battery. I'm basically showing the construction and dismantling of that battery. So there's lots of videos on here, so it can help you. But we're going to be moving them over to the ConsuLab page as well, part of our partnership with All EV. So just giving a couple examples, so you'll see some of the things here that we're involved with, the cutaways and so on like that. Oops, I'm gonna move on. The big thing comes down to curriculum. What do you need to do to start off with electric vehicle service training within your school? And once again, we know that we talk about advanced vehicle technologies. This could be from ADAS systems, even to the tire pressure monitoring and how it's changing and how systems are being monitored and so on. But once again, getting into the development of electric vehicles, and this is a short course list of some of the things that you would typically teach with an electric vehicle course. And as you notice, as you move through the list, if you're seeing this, we're talking about safety, we're talking about the systems and how they work, and you're talking about even into hybrid stuff. But then as you move down, you notice that batteries and that is towards the end of it, because in popularity and understanding how to rebuild a battery, I always ask, especially technicians in shops, how many times do you guys rebuild transmissions? How many times do you rebuild engines? It's, if you need an engine, you buy one complete or you buy it used. And I feel that, I've taken apart well over 50 electric vehicles and basically tore them down and either scrap them or use them as training aids. And I'll tell you that these batteries in some of these cars are not that easy to service. And there's a lot of challenges when you're rebuilding or trying to recondition lithium ion battery in a vehicle. There's a balancing problem, there's resistance problems, there's construction issues. We take apart Tesla batteries all the time from the Model 3 and Model Ys. And they're a big challenge. And so I try and say, don't worry so much about the batteries, but worry about teaching high voltage safety. So, that's really where the meat and potatoes will come from, is from that safety aspect, and then understanding the systems and how they operate and power flow and so on.
We often get very excited about the latest and greatest technologies, the most technologically advanced things that we want to teach, we want to share with the students, and we want to learn about it ourselves. And it's like, when 8, 9, 10 speed transmissions come out and the latest direct injection engine with a turbocharger and all kinds of variable valve timing and really cool stuff. And we want to teach about that. We want to show everyone, but in reality, we don't typically fix that much of it. The students don't really get into it, and we got to teach them the basics. And it's the same thing with EVs. We've got to, look at all these great things that we want to talk about, and we're going to fall back to safety, maintenance, the nuts and bolts of the basics of stuff that's going to wear out on the cars, where there's a lot of overlap with combustion powered vehicles, and then just going through the motions of practicing the safety, understanding how the system works. If we look at a lot of these EVs, they have very large, complex temperature management, thermodynamic systems for cooling the battery, heating the battery, cooling the power electronics, cooling the cabin, heating the cabin. And a lot of that is stuff that's going to need service because it's got coolant, refrigerant, and all kinds of moving parts that are going to wear out long before the battery does. So it's choosing which parts of these curriculums, where are you going to begin, where are you going to add in a new part to your program to cover it. It's going to be safety, basics, and probably into air conditioning.
Yeah. And one thing I want to point out too is electrical electronics is a really big fundamentals with high voltage vehicles. Understanding electricity, understanding power flow is a paramount fundamental for electric vehicles. So having understanding of using meters and scopes and understanding wiring schematics and so on, and understanding the basics of electrical, like all these things from your AC to DC, it's like, is paramount part of electric vehicle training. So,
yep.
So tools and equipment, I put this slide up here. It can be a very vast list. I could add into thermal cameras and so on.
Yeah.
But thing is the basics come down to the safety equipment, the PPE, and you want to design that safety equipment and make sure you source it based around your program, what you're looking at delivering within your program itself. So if you are going to get into batteries and you want that part of your program, you want to be able to remove them and take them apart and show them, then you're going to need at least a level 2 arc flash protection. You're definitely going to need, your gloves and so on. But if you're just doing a maintenance program, it's just going to show, like, we want to show how an electric vehicle works. We want students to understand it, but we are not touching high voltage systems. So our systems, our program is only on basic maintenance, tire servicing, brake caliper servicing, very, cabin air filters and, very basics, and they're not touching the high voltage system. So, so your PPE is probably going to be a lot less than somebody that wants to incorporate a very big program part of it.
Yeah. So this list be a good starting point for a program that wants to go a little bit farther into that. If we look, most programs pretty soon, if not already, are going to have to, at the very least, be able to bring the students up to the point where they depower a vehicle.
Yeah.
Depower the high voltage system without opening any of the high voltage and working on any of the high voltage systems or the subsystems, but getting to that point. So getting to that point is a good objective, I think, for a lot of schools, not necessarily a high school, but for a college level program, getting to the point where your students, when they leave the program, that they are comfortable and have gone through the motions of depowering the vehicle so that it would then be ready for service to be worked on one of the high voltage components so that you could pull something off, change the part, put it back together. That'd probably be a good goal for most colleges.
Yeah, one thing I want to do is the last 3 things. There's your vehicles that you source. Like I know a school down here called me up and they have a Polestar that was going to be donated to them from a school out in Ontario. And the problem is the Polestar is not a very big vehicle around here. So teaching on it would be, it's a car probably they won't see very many out here in the intern. But so one thing is, you look at the vehicles that are on your roads today, do a little research, find out what they are. If it's the Nissan Leaf, the Chevy Bolt, the Teslas, and so on, then those are vehicles that you want to have accessibility too, because those vehicles are obviously going to see on the road. And then your training aids. Once again, you want to be able to demonstrate safe operation, system components, and so on. And this is a big part that we spend a lot of time at ConsuLab, is to find a way that we could demonstrate high voltage systems in a way that makes it real, but at the same time gives the students and the instructor the level of safety and security that they know that, on this training aid as they're learning, they don't need to have to worry about being harmed by the high voltage systems.
Yeah.
And the last thing, the most important, is who's going to teach it. One of the things that we have to think about is that as instructors, you are the major equipment in delivery. It's the most important. So, instructor training, I know, because electric vehicles are fairly new. Within the last 5 to 8 years, they've really come on, and most instructors have very little experience with working on EVs in the industry, in which it can be very intimidating for an instructor to teach on a system they've never even worked on before. And even out here with shops themselves and technicians that are apprehensive or intimidated and do not want to touch these vehicles, I can just imagine instructors that are having to teach these systems that have not had that training or had that experience with EVs. So, and one thing I know, oh, sorry, go ahead.
I was going to say, so of course, at ConsuLab, of course, we want to offer you the help with the last 2 items, and we'll talk a bit about that. Not too much, but we will talk a bit about the stuff that we've been working on and how we can help you to bring your knowledge up and bring your programs up to be able to offer this type of stuff.
Perfect. Yeah. Let's go move on. So I got some weird stuff going on here. Let me just shut this off here. Okay. So anyway, so once again, some of the training aids that we have, is one of them is a full vehicle, but it's and somebody would look at it and go, well, that's a Tesla, and we don't have it. It's the reason it was selected was just because it's an EV with all the components that can be laid out, easily identified and seen, and so on. But if you look on the left side, it really talks about the systems that you can teach about, or that you need to, for students need to understand, is these are the components that are common to all EVs. So, so they all have inverters, contactors, DC to DCs, and, they have high voltage AC compressors. Some of them, if it's a hybrid, and that might be a hybrid type style compressor. We have thermal battery systems, whether it's coolant or refrigerant or even just heated batteries. So the beauty of these is that it gives you a full menu of requirements that you can add into your program to help teach what those systems are.
So this is the flagship ConsuLab product for teaching EVs. There's one behind me. If you look through the window behind me, we've got one here, and of course up on Dave's screen. And this product is designed to cover all the explanations, all the systems, and do things that you can't do unless you're driving down the road with a whole bunch of students in the car and showing them live power flow through all the components and all that. So it's something that's really, really cool. I invite you to check it out both on our website and on our YouTube page, and write to us for more details. That's the flagship right up here, and that's something that I hope many schools will aspire to having, of course.
Yeah, and the thing is too, I want to be also is that I was at a group we were talking, and it says one thing about teaching EVs is, like, how much can we actually test on them? Like, what tests are there? We test the battery, we test past the contactors, and we don't, and this is just one page of several pages of tests that can be performed on an EV. So, and actually this is going to be one of our trainers that we're incorporating. We're taking all the different tests that can be done on an EV and incorporating it onto a smaller student-based trainer that they can perform all these tests with the outcomes, and then go to a vehicle and actually do these types of tests. But it's really exciting for an instructor, because if you don't have a lot of experience, this will also give you the ability to learn quickly and understand what these different types of tests are and how they work and what they do. So I said, oh yeah, I said, it's like, you have no, like, there's so many different tests that you can do, and this is only a small portion of all the different tests that can be performed on an
and
EV.
just for someone who's never worked on an EV before, these are the types of tests. So the list that we've got here is not comprehensive, but it's a long list of many of the types of tests that you would do. You know, when you open the hood and you see a bunch of orange cables, and then you see someone go through all the motions of doing the power down, getting their gloves out, you know, and either doing high voltage measurements, mega ohm meter measurements for isolation tests, milliohm meter measurements, kind of like a voltage drop test to check the quality of the conductors. The tests they're doing when suited up, this is kind of a small taste of all the different types of tests you could do on a car when you're servicing it, or on a ConsuLab training aid, if you were to get one, that it would let you do all of those measurements to practice and to understand and diagnose. So it's quite interesting.
Yeah, so we're, you know, once again talking with the integration with the EVs into your classroom. So I just want to be clear that there's lots here. I want to kind of leave it open for questions now. So
we've got a couple of them ready. So yes.
Perfect.
So yeah, I'll bring up the Q&A here. We have a couple that I know Jimmy had taken a look at. So one of the first questions was from Nathan, and not me, another Nathan. Are we aware of any safety standards for working with in and around high voltage systems that are specific to the automotive industry? A lot of literature that he's come across has been from utility power companies. So I know, Dave, you're involved in some of this, so I'll let you answer that one.
Yeah, so there's a move in the industry to regulate and to give standards around high voltage safety. CSA in Canada, who's I'm working with right now, and there's probably some instructors here on the call that are also involved with that exact same program that we were blueprinted to high voltage safety certification for automotive service technicians, and then they're doing a truck and transport one. I know SAE is also developing standards around that as well too, as well as ASE as well too. It's created a safety program, but to put it at a government level, it's going to take a few years. You're right. I know GM uses a lot of utility programs in the past with their requirements, and sometimes it just doesn't work with our automotive industry. So we're starting to create some sort of standards around that, and that's why we encourage instructors or even industry people when these come up, when there's steering committees come up, or there's anything like that, to get involved with these organizations that can really help change some of the standards that are out there to make them more relevant to the automotive industry.
So I guess for Nathan, for that, it'd be depending on where you are, what state, country, or province you may be in, is looking at your local. If your school hasn't adopted a standard for your program, it's probably going to fall on you. Look at state level or your jurisdiction level, country level, and see. And if there isn't any, then you can lean on third-party certification. Another great resource is to look at what other schools in your area or leading schools in your state or in your country are going for, and kind of jump on board with them, follow in their footsteps, because there are a lot of schools that have gone for different types of certification.
Yeah.
So there are a lot that we're still falling on utility and for electricians and utility power certifications, but there's a lot more that are being developed in the automotive realm.
Yeah.
Then there's one other question here. We'll be able to get this PowerPoint to use in your classes. And that's a question from Tony. And yes, I think that what we'll be able to do is take this PowerPoint and publish it on our website. We have tons of documentation on our website. we have an entire place for files and all that for you as instructors. So what we'll do is we'll publish that as a PDF. You'll need a login. It doesn't cost anything. It doesn't obligate you to anything. You get a login, you go in, download the PDF. We'll do that after, and we'll send an email out to all of the participants to get you to give you that link. And then there's a question for Jimmy.
Yeah, there was a question about a price or something related to the EV601, the Tesla training car, which is amazing. We don't want to turn this into a sales presentation here.
No.
So if anybody has inquiries on any of the products we offer for EVs, which includes the EV601, we have, in my opinion, the industry's best ADAS trainer, which goes far, far, far beyond calibration and truly covers every aspect of ADAS. If you need quotes or more information on those, the easiest email is sales@consulab.com, and somebody will get promptly back to you on that. We just don't want to turn this into a true sales pitch. It's more meant to be educational than anything. So,
but also thank you for asking.
Much thank you.
And now's the time for any other questions to put in to submit. Otherwise, we'll wrap this up. So we do have some dates. We can announce the first one now while you're typing your questions. Jamie, do you have the date in front of you? Otherwise, I will pull it up.
I do not have that date in front of me. There's a new question. How much, you look it up, you look the date up and I'll read it. How much does an average EV battery weigh? And since EV batteries are very heavy, how much electric drive power is used just to carry the battery weight down the road?
Well, that's a great question. I love these questions. It's like, yeah, so it depends on the kilowatt hours of the battery, and the type of battery will dictate its weight. But typically a battery will weigh anywhere in around the 800 to 1,100 pounds. That weight is in comparison to a gasoline engine and powertrain and gas tank full of fuel and stuff. So how much energy does it take just to carry that battery down the road? That's a great question. I don't know how much it would. The math would be
rather complicated.
Yeah,
but
most electric. Yeah, most electric vehicles use between 15 and 20 kilowatt hours to travel 100 kilometers. So that's in distance wise. So, sometimes people ask, how far can your EV go based on the size of battery, but how much does it take in that energy to actually propel just that battery out of that 15 to 20 kilowatt hours? So yeah, great question. I don't know the answer. But it's definitely
the math would be.
Yeah, the math will be interesting. It might be a good question for one of my engineering buddies. So
the weight definitely does impact the amount of available range we get from an EV. But of course, and it's diminishing returns because you can't just put a Honda Civic and put 200 kilowatt hours of battery in it. The thing would weigh 5,000 pounds, and it'd have to drag that 5,000 pounds everywhere it went. So there is some diminishing returns there, but it's a good question. And at the same time, these are the types of questions that are really good to promote discussion with your students and going, okay, what's the use case? Where are electric vehicles best used? What are the benefits of having an electric vehicle compared to a combustion vehicle? Because over long distances for long haul trucking, that's not the great use case with the technology that we have today. It doesn't really work that well. Whereas for suburban or metropolitan big city, you're driving around doing typical use, there's a pretty good use case there. So it all depends. Those are great conversations to have with your students, and these are things that you can integrate in your classroom today. So the next webinar date, please mark your calendars. It'll be November 8th. So that's the day after Election Day in the United States, November 8th at 1 o'clock, same time, same place. New subject. What I would love is looking at some of the subjects we've put up here: high voltage, training aids, isolation testers, EV systems, battery construction, and course ideas and curriculum ideas. Please go ahead, put your suggestions, ideas in the chat. If there's a specific one you'd love to see us discuss, let us know, and we'll announce that within a week or two for that date.
Another question.
Great.
How integral is the response to an emergency covered as new safety concerns arise with EVs?
So I think they're talking about the first responders. Am I
Yes.
correct? So
Yes.
first responders. So I work with 2 OEMs currently, and as a vehicle is being produced on the line, that is the very first thing that is actually produced as the first responders requirements or curriculum. So it happens almost instantly with the vehicle technology. And that's a great question. And I don't have my stinking phone with me, but if there is an app on a phone, there's an app that's fantastic out there. It's called EV. Oh my gosh, I'm going to probably have to give I think it's called EV response. I'm pretty sure it's called EV response. It's totally free and it has all the first responders guides on this app. But even so, if you're not even doing first response training, but it's a great resource to find where the disconnects are and the high voltage components. Some of them are very, very detailed, like the Nissans. Some of them are a
It's a
little
great
less.
source. Yeah, it's a great source for information because manufacturers of all the information for any vehicle that is an EV that you want to talk about in your program, the easiest information to get service information wise is to get the first responder stuff. If you pick whatever car and you go first responders information for that electric vehicle, you can find tons of information. Where to cut, don't touch this, don't lick these wires, don't do that, and you'll get tons of diagrams, tons of information. It's a great source of information to share with your students. And that's something that all the manufacturers are very, very forthcoming with. They're sharing that. And it is very important for the first responders, but also for technicians and for the recyclers. We have another question.
Another good question for both of you as Canadians, especially. What are the EV battery limitations in cold winters?
So what are EV battery? Yeah, sure.
You want to go for that, Dave?
Yeah, it comes down to temperature wise. So the thermal management systems of today's EVs I'll talk about is with preconditioning the battery. So really the range loss on a battery comes about from, where a car has to warm its battery up at the same time as powering the vehicle. And of course, within the battery itself, the movement, the electrons within inside the batteries are very slow. So you have power loss and so on. But one thing and you do lose range. And it's no different than a gas-powered vehicle. Not to make any excuses with either or, but the thing is, temperature does affect the batteries. But with preconditioning and new technologies within the thermal heat pump systems within the vehicles, it's actually less and less every new model that's coming out. And I know with ConsuLab working on this new heat pump trainer for thermal management of the battery system, we've been doing a lot of research on especially newer technologies. Years ago, it was a crapshoot with very cold temperatures on batteries. So they used to put big heaters inside batteries and would use the high voltage battery to heat this huge PTC heater in the battery. And of course it would just chew through the battery itself, trying to keep it warm. So
for older cars with older technology, if you're in a cold environment like where I am, you're like half of your range.
Yeah.
When it's really cold. Now I'm talking really cold. With the more modern vehicles, if you go take a vehicle brand new off the lot with a heat pump technology, you're not losing nearly as much range. And like Dave said, a lot of the preconditioning is one of the luxuries of having an electric car. You don't need to do a remote start to heat it up. While it's still plugged in, you can tell the car, hey, either cool the cabin if you're in Texas or California, or heat the cabin if you're up where we are, and heat it up before we leave. So that can alleviate a lot of that. But for the older vehicles, they take a really big hit in cold weather.
Yeah, and one thing you do is that you're asking these questions, I'm keeping notes. So there is websites and that talk about that range loss, and you can slide bar the temperature, and it shows you how it'll affect all different types of vehicles. So it's really, really kind of cool. So
so we've got another question here that I'd want to answer. If you want to go ahead and ask it, Jimmy.
EV undercoat. Dealers are telling customers it will void the warranty. There are ICE vehicles from 2013-14 in Prince Edward Island with holes in rockers and floors. What is your take? Do dealers want them to be disposable?
I've done entire, there is I do have a webinar. I believe I can send it out, and we may put it on. It talks about warranties, what they mean, and how they affect with any kind of rust protection. One thing with rust protection on vehicle is any accessory gets applied to a vehicle. If that product damages a component, obviously, if they open up an inverter and it's full of, this product, then and the inverter's failed, then obviously it was damaged because of that. But it
Yeah.
doesn't void, it would void the warranty repair on that component at that time, but it doesn't void the warranty on the car. And one
Yeah.
thing we talk about with the electric vehicle and rust protection is proper application, training. Don't spray the orange cables with a black product. That would just be, bad. And you don't need to spray the battery with the product either. You're still dealing with the regular, and just as you mentioned, the holes in the rockers, holes in the door. I've had Teslas where the front rebar on the bumper is rotted right out, because they're steel, they're metal, they're still cars at the end of the day. But it's
So
important to, when you open the owner's manual of a vehicle and it talks about warranty voiding. I actually, in the video, I actually do, like I do all sorts of manufacturers, show the different, and even some manufacturer even state that extra rust protection may be required in vehicles in high salt areas. So,
yeah.
and they don't mean just randomly spraying the vehicle, but being applied properly to the vehicle. So, sorry, Nick,
So
go ahead.
yeah, I would just say firsthand experience and seeing in the market around here, where there are more electric vehicles and plug-in hybrids. Yes, you can undercoat them. Yes, you can do the rust proofing. It's the same thing. It's still a car. It's a monocoque vehicle made of steel with painted parts that are going to rust. You're going to get a hole in the floor. It comes down to the same thing and the same need, which is the training around that. So there are undercoating shops in the town where I live that their marketing advantage is they do EVs. They undercoat EVs and they're careful about it, and they go through, check the manufacturer specifications, and they only undercoat the parts that are going to rust out. Your rocker panels, your floors, your fenders, and all that fun stuff. So it's that same point that we've been hitting home from the beginning. Is it's still a car, still a lot of overlap. Yes, we have to be careful, but there's a lot of it that it's going to be the same and it's going to be all right.
Yeah.
So
and one other point is, oh, sorry.
I was going to say, I think with that, we're right at the top of the hour. We're going to wrap this up.
Yeah. Oh, sorry. Yeah, we're right.
Everybody who registered here, we do have your email. We will send you the recording. We'll send you where to find the recording. We'll send you where to find this documentation on our website, and we'll keep you up to date on our next event, which is going to be November 8th. It's exciting. We went from Nova Scotia to Alaska, so we went to extreme coast to coast, covering a topic that needs demystifying, in our opinion. That's kind of the point of these webinars, is to help demystify everything. So we sincerely appreciate everybody's time to this topic, and look forward to hearing and seeing from you now and in the future.
Great. Thank you much. Thank you very much, everyone, and have a great day.
Thank you. Bye-bye.